So I've just finished recording the first part, and that one is actually currently uploading. But nevertheless, I'd like to, well, go on with the second part right away. So today, or now, I am actually might upload this part today as well. So today we would like to have a look at, or now we'd like to have a look at variables, as I've promised at the end of the last video, or last part of this course, which I've actually decided to call Rust Introductory course. Right, so, and why am I showing you this? That is, I don't know if I'm going to move it to another account because it looks sort of out of place on my GitHub page, but Rust Introductory course, that is the repository's name. If you don't know what GitHub is, that's okay. Just think of it for now as a page where you can basically upload your folder where all your coding files are in. So, but that's not exactly what it is, but think of it like that if you don't know what it is. And here you can browse and just compare your code to mine. You can simply go here to the main folder and then you will have a structure like I hope you have as well. Good. So that being said, I'd like to continue. And once again, if you have any questions, you can ask me in the comments below or on Twitter, which is Lucas A. Miller here. It's my page. You can also follow me if you want to. It's always welcome. So, you're always welcome, and now we're going to start off. What I noticed is that in the last video, in the last part, I did not explain really what cargo new meant. I only executed it. I didn't even... No, I actually think I haven't talked about it at all. That might have been because I was in a rush, I could say. I just wanted to get right into the cool stuff, and that is what we're doing now. So me saying that, and if you are a beginner, no worries. Good job so far for following along. It's weird to install your first programming language and all those kinds of things, so good job. But I suppose no one's gonna start off with Rust, so I guess not many people will actually call this their first language. Anyways, cargo new, and then the name basically just means create wherever you are right now. We'll call the package manager. That's the command. New means just new project basically, and then the name of the project. And then we could actually hit return now. But if we say this dash dash bin, you call those dash, not minus. Dash dash bin. Bin stands for binary application. And you know what binary is, I hope. If not, I actually might make a video on that, like computer terminology basics or something like that. Yeah, because I mean, some people who don't even do programming know about binary and even know the real concept behind it, but some developers actually don't know about binary. Obviously not those who went to uni, but still, it's important to know it. Okay, but you can survive. You can survive without. You can really do, but you won't do hardware stuff anytime soon if you don't know binary. That's for sure. You might do web programming because there you don't exactly need it. I'm not saying you don't at all, but most of the time you don't. So where I have to head into my folder actually, Rust lang, and then here I actually created another one which was course, and then in here, yeah, there you go. That's where my file is. And now if I say cargo new o2 and then variables, because I suppose it's what we're only gonna cover now. We also say binary, so we can simply execute the application, or the, oops, that's not what we want to do. We're here, course, and that's the folder that we need. There you go. So, good. Let's make this. Let's actually turn it full screen. And now, here's main. Okay, that is good for now. That's what we need. We need nothing else in that, but we can delete everything that's inside of here. So how do we start off with a variable? What's a variable anyways? Just really quickly, if you don't know, a variable is just something that stores information for us, basically. It could be a number, it could be a number with a decimal point, just a decimal. You could have a string, which is text. In Rust, we can even differentiate between characters, since strings, a character would be initiated with those characters, a string with those, but that's not important. You can also have just an A like this and it would be a string, but then you could have it like this and it's a character. In most programming languages that isn't like that, but in Rust it is, so that's good to know. But it could also store a bool, which is either true or false, so basically like binary, right? True or false. 1 or 0, or 0, 1, whatever. Then what we also have is, well, I think that's enough for now. So what we can do is start off with the word let. In most programming languages, a variable would be declared with a var, and that's okay because let is not a variable. You could call it a constant, but in Rust we actually call it a variable, which is maybe confusing at first, but that's what it is. So let, and in order to actually call it later, because obviously if you assign it a value, you want to use it later on. Otherwise you would probably not declare it. There are cases where you do, but not often. So let's just say this here is going to be pi. And now if we say equal, that assigns something. Here we actually assign, that's what you call this process, pi a value. It could be a word now. You could say this, and it would be a word, but we want to have a number, and 3 would be, as of now, nothing, because as soon as we run the compiler, or actually I'm not sure about this, if Rust is compile time. Is Rust compile time? I actually don't know how to formulate this question. So the idea is just that in a few programming languages, the type of something that you declare is here. The whole process you call declaring. You declare a variable, but here you assign it a value. The thing is that, for example, in a Go programming language, if you have a number, there are all different kinds of numbers. And at compile time, so when you run, it decides on which type it really has to be of number, for example, until then it's of type kind. In Rust, I suppose, because it's Rust, I think you have to do that before compile time, so it's before. I think, I'm not sure. So here we have 3.14, or as we say in mathematics, 3.1415, and that should be enough for now. So why waste time on this any longer? And then we have a colon here, a semicolon here, because that's what we need in Rust in order to, well, say here it stops. In most modern languages you don't need that, but in Rust you do. So if we run cargo run, it's going to say unused, and it warns us, hey, this is not nice. Because this is pollution, you call it in Go at least. So unused code, something that you don't. So this is saved somewhere in your memory, but it is never used. So why do that? And if we put this piece of code right there and run, oops. Yeah, I've actually never used them, so let's ignore. Sorry about that. I've never read about it, never felt the urge to learn about it. Might now. So here, let pi, and it has a value. Okay, so the problem is Well, we don't know really what type it is, so let's see if we can print its type. Rust print type. How do I print the type of variable in Rust? And is there a nice way of doing this? Here, apparently get like this. So that's what we do. Okay, so first of all, we have to use a macro, which is a piece of code that does something for us, which is within a programming language. So it comes right away. And for example, here we could say hello world again, right? That's what we had. But now we want to have, if you say pi, it would not print us this number. It would print us pi. But we can change that in order in a way where we just have to say here curly braces and close them again. And then we can say I love it was pi day. That's a joke. Pi day a couple of days 4 days ago, I think. No, 3 days ago. It was pi day 3 days ago. Actually, that's true as of today. And if I run, oops, if I run, it's missing something, which is if we have 1 here like these, and we put in pi at the here afterwards with comma, we pass in 2 arguments, it will print us the, what's the issue here exactly? Something's wrong. Oh, we didn't save. There you go. I love, and then you see, it was Pi Day 3 days ago. It worked very fine. It printed out its number, and that's good. But now, what if we were to change the number of pi, and you wouldn't do that, right? And the reason for that is let by default is immutable, meaning not changeable. And that's why Rust is a bit confusing because they do call it variable, even though in other languages this is called a constant. In order to make a variable, as they call it here, mutable, so changeable, you don't say var pi or whatever, you say let mut. So let mut, and then you can declare something again, and then it's changeable. So we could say, for example, current car num, and we name variables like this, not car num, which is, or car num like this, and especially not like this, because we can't have spaces. But you do snake casing, I think you call it, car num, so car number, and let's just say that is going to be my favorite, which is 9. And just in case you want to know, the type can be declared too, which is by a colon right after pi, and then it has some value, which for example here could be not I, and then 8 or 64 is something to do with bytes, again, how many numbers can go in here. But we could have, for example, float 64, which is, float is a decimal number, so you can have a point. But why do that now? We don't need it. So here let mut carnum is our number. And now we could say print, again, the current number the current num is, and then print a number, semicolon again, and it's print. And here you see it, well, actually it complains, why is it mutable? It doesn't need to be, you never change it. And that's good, because sometimes when you code you do that and then you're like, oh, right, never meant to actually say mute, or you forgot it and then you're like, oh, there it has to be. And many programmers actually just go for let and change their variables values at some points, and then the compiler just tells them, here, you changed that, but it can't, it's not mutable, and then you just change it, and that's how your code will stay always top notch. But it would be cool if you know it yourself and don't always well, look what the compiler tells you. That's sort of not what Immanuel Kant told us to do, right? He told us to think ourselves and experience ourselves, experience for ourselves. So that's important too, because Kant said it. So, right, now having said this, we want to change the value, which is just if you call a name and assign a new number. What would be a good number? Let's go for, well, the number that most people have is their favorite, which is 7. And then if I print again, we will have something like this here. The current number is 9. You see, even though we change it, this stays 9 because obviously it's all changed after the statement. So you know now that an application is also executed from the top to the bottom, which is not always the case because we can have exceptions in there with programming concepts like parallelism or, well, concurrency. But don't get confused now. You don't need that for long, I guess, if you start into Rust now. Okay, so that's good to know. We just changed the value, and we can also obviously do one more thing, which is we could, for example, what could we do? I don't know. Why ever we would do something like this, we could around circle. How many times do we want to go around it? That would be 2 times pi times, well, the amount of times that we want to actually go through it. Because pi is 180 degrees and a circle of 360, so that's 360, and then here car num is just how often we go around it. Okay, and then we assign it to this guy, and if we run for now, it's going to say, oops, doesn't work. Why not? Because here we have 2 different types, which is number 1 integer, so not without a decimal,